Hello friends, welcome back to my YouTube channel. So in this video we will start the new chapter, that is slope deflection method. So for that, before moving to the problem, we will see the some basic concept of this slope deflection method. This is the simply supported beam, one end is fixed and other is hinged. For calculating the moment, we have the formula that MAB is equal to MFAB plus 2EI divided by L into 2 theta A plus theta B minus 3 delta divided by L. So this is the formula for A to B. Here the formula is different for moving from left side to right side, that is AB. For moment about AB is a different formula, and BA we have the different formula. So when we move from left side to right side, it may be any point, either AB or BC or CD, any point. We need to apply this formula when you are moving from left side to right side. We all know this is our left side and this is our right side. So for when we move from the right side to left side, we have to apply this formula, that is MPA is equal to MFAB plus 2EI divided by L into 2 theta B plus theta A minus 3 into delta divided by L. When we are moving from right side to left side, it may be BA or CB or DC, any point. We need to apply this formula. The formula is same, only the thing is here alphabet will get changed according to the points. Here also according to the span we need to change the alphabets from A to B or from B to C or C to D. If we want to calculate from B to C, here we need to apply the MBC is equal to MFBC plus 2EI. 2EI divided by L, 2 into theta B plus theta C minus 3 alpha divided by L will come. Here one more thing is, we need to multiply the, here first alphabet is A. We need to multiply twice into first alphabet, that is A. Here also we need to multiply. Here the first point is B. For B we need to multiply 2. That is 2 theta plus 2 theta B plus theta A minus 3 theta I divided by L. So in this formula we need to find out the MFAB. MFAB means fixed end moment of AB. We need to find. For that, finding the fixed end moment, we have one formula. I will explain that later. And here 2EI divided by L. 2 into theta. Theta means slope. At fixed end, slope is always 0. So here at fixed end, our theta is equal to 0 at fixed end. You need to remember this one. This is in hinge. So in the theta is not equal to 0. Here what happens is our moment is equal to 0 at this hinge. So here what happens, theta is equal to 0 means here 2 into 0 becomes the 0. Here theta B is, here theta is not equal to 0. Some value will come here. Minus 3 into delta divided by L. Here delta means in some problem they will give the deflection. The deflection of 2 mm, 5 mm like that. If they mentioned in our question, then we need to substitute that value. In case of 3 delta divided by L, if they are not mentioned in our problem, we need to keep it at 0. Only we need to substitute the value when they are mentioned in our problem. See here theta, if the deflection is given in our problem, then take that value, substitute that value here. In case of minus 3 delta divided by L, if not mentioned in our problem, we need to keep it as 0. And one more thing is formula is same for all type of the beam. It may be one end is fixed or another is roller, or one end is fixed another is hinged or roller. Here also the formula is same for all type of the beam. Here what happens, at fixed end our theta is equal to 0, at roller our moment is equal to 0. Here theta is equal to 0, here moment is equal to 0. We need to remember this one, theta is equal to 0, and theta means slope is equal to 0 at fixed end. So here our moment is equal to bending moment is equal to 0, because at simply supported end our bending moment value is 0. So here also 0. So I will write here at fixed. So theta is equal to 0, bending moment is not equal to 0. So at inch, or you need to remember this while it is useful while calculating the problem. At fixed our slope is equal to 0 and bending moment is not equal to 0. At hinged our slope is not equal to 0, our moment is equal to 0. Here at roller also our slope is not equal to 0 or moment is equal to 0. This you need to remember, it is useful while solving the problem. So next we'll move to the formula. Here for find outing the MAB, we need to find the MFAB. MFAB means fixed end moment for AB. For calculating the fixed end moment, we have one formula I will show. For calculating the fixed end moment about AB, we have the formula. See here our beam is here simply supported beam. The load is coming at center at a distance of here L by 2 and L by 2. So this is the diagram. Bending moment diagram will come like this. And for find outing the fixed end moment, our MFAB is equal to minus WL divided by 8. A to B from left side to right side. We need to calculate by using this formula. MFAB is equal to minus WL divided by 8, because it is anti-clockwise. And for MFBA, we have the formula WL divided by 8. It is moving clockwise. When the load is acting at the center, we need to use this formula. When our load is not acting at the center, we need to use the formula MFAB is equal to, for this kind of beam we need to use this formula. Here one more thing is, finding the maximum height, we have to use the formula, that is WL divided by 4. So by using this formula we will get the maximum height of this diagram. And when it comes to the beam like this, which is not acting center, and by using we need to use the formula MFAB is equal to minus WAB square divided by L square. For AB, for find outing the fixed end moment for BA, we have to use the formula WA square B divided by L square. We need to apply this for finding the fixed end moment for BA. And to find out the maximum height of this, we have the formula WAB divided by L. So by using this, we'll get the maximum height of this. So next we'll see the fixed end moment for this kind of beam. Comes to this kind of beam, it is the UDL is acting. The bending moment diagram will be parabola. To find out this maximum height, we need to apply the formula WL square divided by 8. And to find out the fixed end moment for AB, we need to apply this formula minus WL square divided by 12. Minus means it is moving anti-clockwise. So for find outing the MFBA from B to A, we have the formula WL square divided by 12. By using this formula, we will calculate the fixed end moment for AB as well as BA. So next, when we come to the this kind of beam. So this is the simply supported beam subjected to the concentrated load at center. So to find out the fixed end moment for AB, we have the formula MB into 2A minus B divided by L square. And MFBA, from B to A is we have the formula MA into 2B minus A divided by L square. By using these two formula, we will calculate the fixed end moment for this kind of beam. And here the maximum height we have to calculate by using this portion. We need to calculate by using the formula MB divided by L. And to find out this portion of maximum height, we have the formula MA divided by L. So these are the formula for find outing the fixed end moments for AB and BA. So after find outing the fixed end moment, we need to apply these values in this formula, that is MFAB. After find outing the value, we need to substitute that value to here, and also by using this formula, we will calculate the bending moment about AB and BA. These are the formula for calculating the moment about AB and BA. Now we will see the procedure of slope deflection method. So to find the slope deflection method, so we will see one by one step. First step is to find out the fixed end moment of AB, BA or BC, CD, etc. So by using this formula, we need to find the fixed end moments. Our second step is to find out the slope deflection equation for each span. So for slope deflection equation, we need to use these two formula. We need to apply these two formula. So our third step is to find out the equilibrium conditions at intermediate joints. So we need to apply the equilibrium conditions. So for equilibrium conditions, there will be two cases. So what I said, assume it's a simply supported beams A, B, C. Here moment about B, moment about AB, and moment about CB is equal to 0. So what I said at here at simply supported beam, in simply supported beam, it is the, so here A and C are simply supported. So in simply supported beam, so moment will be 0, bending moment will be 0 at simply supported end. So our MAB is equal to 0 and MCB is equal to 0. So moment will be 0 at hinged end. And so I have already explained here, at hinged moment is 0 and at roller also moment is 0, bending moment is 0. So here A and C are in the support, or bending moment will be 0 at simply supported end. So this is our first condition. So our second condition is, I will explain here. This is the fixed A and this is point P. This is the case 2. So it's case 1. This is case 2. So in case 1, what happens at simply supported, our bending moment is 0 at hinge support as well as roller, as I told you. So this is a simply supported. Here what happens, our MBA plus addition of MBA and addition of BA and BC is equal to 0. Here the answer will be, when we add moment about AB plus moment about BA plus moment about BC, it will come out as 0 and our answer will come out as 0. The addition of these two will be 0. This is our case 2. While solving the problem in details, I will explain. So our next step is to find out the final moments, and after that find outing the support reactions. And after find outing the support reaction, we need to go for the drawing of SFT and BMT diagram. So these are the steps we need to, according to these steps we need to solve the problems. So while solving the problem in details, I will explain how to solve this. So these are the steps and formula you have to remember while solving the problem. It's useful. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.